In this video, we're going to take a look at section 7.3. How do you tell whether a sample comes from a population that's normal or not? So we're going to use, our objective is to use normal probability plot to assess normality. A normal probability plot is a graph that plots observed data versus normal scores. A normal score is the expected z-score of the data value, assuming that the distribution of the random variable is normal. The expected z-score of an observed value depends on the number of observations in the data set. So we're going to use technology to construct the normal probability plot, but we want to be able to interpret it. So if the normal probability plot appears to be linear, then the sample data are from a normal population. You can check visually, or you can use the correlation coefficient and critical table. It's actually a different critical table than the one from chapter 4. When you're in homework or a test, click on the table so you can see it. So we're going to use technology to create a normal probability plot. So the problem is the data in table 4 represent the finishing time in seconds for 6 randomly selected races of a greyhound named Barbie's Bomber in the 5/16 mile race at Greyhound Park in Dubuque, Iowa. Is there evidence to support the belief that the variable finishing time is normally distributed? So we have 6 values. What we're going to do is we're going to have technology provide us with a scatter plot that has the time, the individual data times. There were 6 data values, and on the y value, the expected z-score. These could be interchanged, by the way, but we want to take a look at the scatter plot. The correlation for this data set is 0.974, and then it's closer to 1. Okay, so a line is a good fit. So StatCrunch. We're going to take a look on how to use StatCrunch to make it. So we're going to enter the raw data into the column, and then we're going to select graph, a QQ plot. So let me get to StatCrunch. So when you're in the homework, click on StatCrunch. We're going to visit the StatCrunch website, open StatCrunch, and I'm going to type those values into the first column. I just need to get the values where I can see them. So the values are 31.35, next 32.06, 31.91, 32.52, 31.26, oops, 31.91, 32.52, takes longer to take the data in than anything else, 31.26, and good thing we only have 6 data values, 32.37. 32.37. Okay, we've got 6 data values in there. So now we go to graph. Normal, a QQ plot is what this is called. Select the column, add the correlation, and then click on compute. So it shows us the graph, and it shows us the correlation of 0.974. Okay. So let's take a look at a homework problem from section 7.3 just to make sure. So let's say question number 27. Okay, so notice right here we have the table of critical values. It says a sample of O-rings was obtained and the wall thickness in inches of each was recorded. Use a normal probability plot to assess whether the sample data could have come from a population that's normally distributed. So we're going to click, oops, I don't want question help. We're going to click and open our data set in StatCrunch. So our data set is already there. So I'm going to go ahead and graph a QQ plot using the variables. Make sure the correlation statistic is there. So compute. So, okay, this looks pretty good. A line that it's linear, and they have a correlation of 0.997. Okay, we've also have how many data points? 16 data points. So when you check to see if it's linear or not, click on the table of critical values. Our sample size was 16, so 0.941 is the critical value. So this is a different table, 0.941, and we had a 0.99. It's higher, so that means that yes, correlation between the expected z-scores and observed data exceeds the critical value. So use the table of critical values here, and then the critical value that you got on your when you calculated it. Okay. So I'll put the critical value that we had, and then here is the value from the table.